Hello students, welcome back. So the prerequisite for this video is watching of AND gate implementation using neural network, and you must have tried out the various other logical gates like OR, XOR, NOT, XNOR. All these logical gates you must have tried out so that it is easy for you to solve this assignment. Right? What are we expecting this? See, since how you implemented the logical gates, now we are extending your learning towards implementing the algebraic functions, right? So we're trying to choose a function in the step one. What are you trying to do? You are trying to choose a function which is a function of two variables, x and y. So I have given some example. You can consider some equation like f of x comma y is equal to x square plus 2y, or sin x plus cos y, or sine square x plus cos y square, cos square y, like this. You can consider some function which is of the consisting of two variables. Then you can fix the x and y values. Say suppose it is x is ranging from 0 to 5 and y is also ranging from 0 to 5. So in order to generate this data, I've given a hint also, right? You can use numpy mesh dot mesh grid and to create the grid, and mp.column stack to prepare the data set. You can use this instruction. You can learn through ChatGPT like how this function works and then generate this grid of points. Once this is done, please try implementing simple feed forward network such that its input layer has two neurons x comma y, at least one hidden layer, and one neuron in the output layer. Right. And this is what the expectation is in the feed forward neural network. Right. So what are we expecting? See how we have used the other loss function. Here we are expecting you to use MSE, mean square error, as a loss function. And optimizer, you can choose either stochastic gradient descent or Adam as an optimizer. You can use either of them. Now, tryouts in a similar way how we tried out in the AND gate, uh, changing the optimizers, changing the epochs, right? Changing the activation function, right? So here also you can change with that. So try out with ReLU, leaky ReLU as a activation functions, right? So once you are done with this, you can plot what are the visualizations that we are expecting is um, plotting the actual function as a 3D surface. Right. Then what are the neural network predictions? First is actual function you have plotted, then neural network predictions you are predicted, whatever you have predicted, plot it on the same such that I'll be able to compare. You can use one color for actual function, another different color for the neural network predictions. Right. So then similarly, plot the absolute error surface in the separate 3D plot. So show me the error, how error is changing. In addition to this, we are pushing you a little, right, to make you to learn about adding a sliders, right? So adding a sliders for changing the azimuth and elevation angles so that you can rotate the plot and visualize it. Right. Once you're done with this, we expect you to compare the predicted surface with actual surface, right? Whatever is the points there. Okay. So please make a detailed analysis where actually your network is performing well and where is it failing, right? So another observation that we want you to look into is what what is the impact of hidden layer size or activation functions on the approximations, right? Both hidden layer size, right? So in the AND gate, we tried out, right? Increasing the layer size from 1 to 3, right? So similarly, try out with different hidden layer size activation functions. I showed you with TANH, sigmoid, and ReLU. So you can try out with the different activation functions and try observing what is its effect then. And the last observation you can make is which regions of the input space have higher errors and why. So that Detailed analysis will help you to prepare yourself for your handling the next coming up assignments as well as the videos. Okay. Hope the assignment is clear. Please complete this assignment. See you in the next video. Thank you.